In this video, we will talk about counterclockwise rotations. We are only going to look at the front page of the notes in this video, and I'll make a separate, quicker video for the back page of the notes. Rotating just means to turn about a point, and in this 8th grade year, we're only going to rotate figures about the origin, and we'll only use rotations 90 degrees, 180 degrees, 270 degrees. We'll also use 360 degrees. Hopefully you remember from the other day when we went over clockwise rotations that to rotate 360 degrees puts us back at the same spot, so that's not actually going to change our figure any. Yep. To rotate a figure, we're actually going to turn our page to get a new graph. Then we'll read and record the ordered pairs. So after you turn your page, you're reading ordered pairs. You're not plotting anything yet. You plot the new ordered pairs after you've turned your page back to normal. Rotations preserve congruence, which means that the image is the same shape and size as the pre-image. All we've done is just rotated where it's facing. Same shape and size. This also means that the angle measures are equal. Rotations do not preserve orientation or the direction that the figure is facing. We need to remember that this negative sign, when it's in front of a variable, it really just means opposite. And opposite just means to change the sign. So positives become negatives and negatives become positives. Now previously we were going clockwise. This is the way that a clock turns. So today we're going to go opposite of that. If I was in a car and I turned my steering wheel this way, my car would go to the left. So we are looking at left turns when we say counterclockwise. 90 degrees is one turn. 180 degrees is two turns. And 270 degrees is three turns. I'm just going to write the general rules for these rotations. 90 degrees is opposite y, normal x. 180 degrees counterclockwise is opposite x, opposite y. 270 degrees counterclockwise is y, opposite x. Now you might notice, especially if you're really diligent at looking through your notes, that this is the same rule as 270 degrees counterclockwise, clockwise. This is the same rule as a 270 degrees clockwise rotation. You'll notice that the 180 degree rotation is the same rule no matter which way I'm going. So clockwise and counterclockwise have the same rule. And the 270 degrees counterclockwise has the same rule as 90 degrees clockwise. So you're using the same three rules, it's just got the order switched. And that's because we're doing an opposite turning. Let's look at some examples. Here I've got that I'm going to use A, B, and C for all four of these examples. A is at -2, 1. -2, 1 is A. B is at -2, 7. And C is at -6, 1. We want to turn 90 degrees counterclockwise. 90 degrees means one turn. And counterclockwise means we are turning to the left. So we're taking our paper and we're going to actually, I'll show you. We have our paper and we're actually turning it to the left. Okay, so now we see that A is now located at -1, -2. I wrote A prime. I know this is A prime because this is the triangle after I have transformed it or moved it. So this has to be A prime or my image. B prime is at -1, -2, -3, -4, -5, -6, -7, and then -1, -2. I know those were negatives because I was going left and down. C is located at -1 and then down, so -1, -2, -3, -4, -5, -6. C prime is located at -1, -6. So we'll turn our page back to normal now. And I'm going to fill in these numbers. I'm just going to copy it down again here so that my notes kind of make sense. A prime is -1, -2. B prime we said was -7, -2. C prime is -1, -6. Okay, so now I'll spend some time to plot that on the graph. A prime is at -1, -2. Label it A prime. B prime, -7, -2, -7, -2. C prime, -1, -6, so that's left 1 and down 6. And I'll go ahead and label this as 90 degrees counterclockwise. Let's look at the general rule for 90 degrees counterclockwise. I'll have a graph. This is normal x, normal y, opposite x, opposite y, or negatives. This would be where your negative x values are, and this is where your negative y values are. We are turning 90 degrees counterclockwise, so one turn to the left. Now, in place of my x values, this is my new x values, and this is my new y values. So in my rule, the new first spot says -y. The new second spot says normal x. We can see that with the numbers algebraically or numerically. When we look, let's look at point A with this. So it says to take the old y value, and that's going to be the new first spot, except for we're going to make it opposite. So I'm going to make one opposite and put it in my first spot. The opposite of normal 1 is -1, and it's in my first spot. Then take the old x value and just copy it down as is into the second spot. We take the old x value, -2, copy it down as is into the new second spot. You've switched the order of the coordinates and made the first thing opposite. Now let's look at 180 degrees counterclockwise. 180 degrees means 2 turns. And I'll specify to the left because this does say counterclockwise. So for continuity today, I will turn counterclockwise. But we know that a 180 degree counterclockwise turn is the same as a 180 degrees clockwise turn. And I can prove that to you here. I've got an up arrow. If I turn this twice to the right, or clockwise, my arrow now points down. If I turn this twice to the left, my arrow still is pointing down. So we're going to take our page and we're going to turn it counterclockwise 1 turn, 2 turns. Now I see that this is my image now because my triangle has moved, my graph has been moved or transformed. So A prime is located at to the right 2 and down 1, or positive 2, negative 1. B prime is located to the right 2 and down 7, or positive 2, negative 7. And C prime is located right 6 and down 1, or 6, negative 1. Now that I have my new ordered pairs, we can turn our page back to normal. And just so my notes make sense, I'm going to rewrite A is at 2, negative 1, B is at 2, negative 7, C is at 6, negative 1. This isn't any new information. I'm just rewriting in this box so that my notes are easy to follow when I go back and look at them later. Now that we've got our image points, we can go ahead and plot them on our graph. A should be at 2, negative 1, so right 2 and down 1 is A, or A prime I mean. B prime is at 2, negative 7, 2 and then down 7, right 2, down 7 is B prime. And C prime is located at 6, negative 1, or right 6 and down 1. And I'll label that with 180 degrees. And just, again, for continuity, this was counterclockwise that we actually did turn it. But that's the same as 180 degrees clockwise. Now let's look at the rule for this. We can come up with the rule by looking at our graph. Here's your normal x's. And if I were to count left, that would be negative x's. Here's normal y's or positive y's, and if we go down instead of up, that is negative y's. Okay. We are turning this twice, 1 turn, 2 turns. That was clockwise, just so you can see a counterclockwise or left. I'll do it this again, going counterclockwise, 1, 2 turns. Now my new normal x or positive x values have a negative x by them, and my new normal y's or positive y's are what used to be the old negative y's. So my general rule for 180 degrees, for a rotation of 180 degrees, is opposite x and opposite y. I'm saying opposite instead of negative because this would just need to make a sign change. If you have a negative of some number, what if I had a negative 3 here? The negative or opposite of negative 3 is a normal 3 or a positive 3. You can confirm this algebraically or by looking at the numbers. Let's look at ordered pair B. My numbers are staying in the same order, so negative 2 will still be in the first spot, but I have to make it opposite. So instead of negative 2, I should have a positive 2, which is what I've got. Again, my numbers are staying in the same order, so 7 is still in the second position, but I have to make it opposite. The opposite of positive 7 is negative 7, which is exactly what we've got down. So algebraically, our rule is verified. So negative 7. That's really hard to see with the highlighter. I'm just making it worse now. Okay. And that's a 2. Yeah, that just made it a lot worse. Okay. Moving on then, looking at a 270 degrees counterclockwise rotation. Counterclockwise means turn to the left. And 270 degrees is 3 turns. So we are going to physically take our paper and turn it 1 time, 2 times, 3 times to the left. Now I can read my new ordered pairs. I know these are the image coordinates because this was my pre-image and I moved it to get this new triangle. It's pointing a different direction. A prime is located at right 1 up 2, or positive 1, positive 2. B prime is located at right 6 up 2, or positive 6, positive 2. And C prime is located at right 1, B is, I miscounted. B is at right 7 up 2. So B prime should be positive 7, positive 2. And C prime is right 1 up 6, or positive 1, positive 6. Now we can turn our page back to normal so we can plot the ordered pairs. And just so that my notes make sense, I'm going to rewrite those prime ordered pairs. 1, 2, 7, 2, 1, 6. And we'll plot those. A prime is at 1 up 2. B prime is at right 7 times up 2 times. And C prime is at right once up 6. I'll label this. This was a 270 degree rotation counterclockwise. And we are going to now look at the general rule here, and we'll see why this makes sense using a graph. Here is normal positive y's, and if I were to go down, that would be negative y's. Going to the right is a positive x, and going to the left is a negative x. This was 3 left turns. 1, 2, 3. And the spot of my normal x values is now a y. And then the spot of my normal y values is now a negative x, or an opposite x. So my rule for a 270 degrees counterclockwise rotation is y, opposite x. And again, you can confirm this algebraically or numerically. We'll look at point C for this. This says take the first number and make it opposite and in the second position. My first number was negative 6. When I make that opposite, it's a positive 6. Positive 6 is exactly what I have in my first position. Or my second position, sorry. Then we look at the old y value, and that says copy it down in the new first spot. The old y value was 1, and we have exactly copied down just a 1 in the new first spot. Now we will look at a 360 degree rotation. I'll use orange for this. 360 degrees would be 4 turns. And again, for continuity today, I'll go to the left. Either way, it wouldn't matter. So I'll go to the left 1 time, 2 times, 3 times, 4 times. And you'll see that my pre-image is exactly where it started. So A is located left 2 and up 1, left 2, up 1. B is located left 2, up 7, so negative 2, 7. And C is located if I go left 6 and up 1, or a negative 6, positive 1. Since my ordered pairs didn't change at all, then I'm taking X and copying it down in the normal first spot, and I take Y and I copy it down in its normal second spot. XY goes to XY. Nothing changes here. So I can say that this was a 0-degree rotation. I can also say this was a 360-degree rotation. And you can verify that again using a graph. Here's your normal Y, normal X. Negative X's are to the left and negative Y's are down at the bottom. When I turn this 4 times, 1, 2, 3, 4 times, X is in the exact same spot, Y is in the exact same spot. That is all the note. I do want to point out one more thing, I'm sorry. My pink triangle was 90 degrees rotated, counterclockwise. This was 1 turn to the left. If I look at turning to the left, that would be going this way, counterclockwise. 1 turn to the left puts me in this quadrant. 1 90-degree turn. Each quadrant is a 90-degree angle. So I go 1 90-degree angle to the left to get to 90 degrees. I go 2 90-degree angles to the right to get 180 degrees. I would turn 3 90-degree angles to the left to get to 270 counterclockwise. And then 4 right angles to the left puts me exactly where I started. So that's a really good way to check yourself at the end of completing a rotation. Look at your ordered pairs and see if they move to the correct number of quadrants. That's all the content I have for this video. If you have questions, comments, or concerns, please reach out to me. You can send me a message on Schoology, send me an email, or drop a comment on this video.